Tired of remembering complex CLI arguments every time you launch your fastmcp server? We'll see how fastmcp run uses a declarative fastmcp.json configuration file to standardize server execution, either by explicitly specifying the config path or letting fastmcp auto-detect it in your current directory. This approach maintains a clear precedence hierarchy where CLI flags override config values, which in turn override defaults, while keeping all server settings in a single shareable file.
Run the server using the configuration. Fastmcp run fastmcp.json. Or if fastmcp.json exists in the current directory. Fastmcp run.
This demonstrates fastmcp's declarative project configuration system, where server behavior is defined through structured JSON files rather than imperative code or command line arguments. The configuration file serves as a portable, shareable definition of your server's source location, environment requirements, and deployment settings. When you run fastmcp run, the system automatically detects fastmcp.json in the current directory, though you can explicitly specify any configuration file for different environments. The configuration approach follows a clear precedence hierarchy where CLI arguments override config file values, which in turn override framework defaults. This allows environment-specific customization without modifying shared configurations. You can change ports, transports, or logging levels at runtime via CLI flags while maintaining a consistent base configuration. The system preserves backward compatibility by forwarding arguments after, directly to the underlying server, supporting custom argument parsing in existing applications. This pattern solves the problem of environment-specific execution while maintaining clean separation between configuration and implementation. Teams can maintain standardized configurations in fastmcp.json while developers use CLI overrides for local testing. The approach works particularly well for projects needing reproducible deployments across different environments, though it's one of several execution modes fastmcp supports, including direct file, object execution, and traditional main blocks for compatibility. Let's break it down line by line.
Run the server using the configuration. Fastmcp run fastmcp.json.
Launches the fastmcp server using an explicit fastmcp.json configuration file. The CLI auto-detects fastmcp.json in the current directory if no path is specified, following a clear precedence hierarchy where CLI arguments override config files, which override defaults. This demonstrates the configuration file execution mode, one of 3 supported approaches alongside file, object, syntax, and direct CLI flags. Arguments after pass through to the underlying application, enabling runtime customization without modifying the config.
Or if fastmcp.json exists in the current directory. Fastmcp run.
This shows fastmcp's config file execution mode where the CLI auto-detects fastmcp.json in the current directory as the default configuration. The CLI follows a clear precedence hierarchy. Explicit CLI flags override config file values, which in turn override defaults. For other execution modes, use fastmcp run my server, MCP for file, object syntax, or override settings with flags like transport HTTP. Arguments after pass through to the underlying application, enabling server-specific configuration while maintaining consistent behavior across environments. Fastmcp configuration execution. The CLI launches servers using explicit fastmcp.json files or auto-detects them in the current directory, with command line arguments taking precedence over config values for environment-specific adjustments. Arguments following pass directly to the underlying server application, enabling runtime customization without modifying configuration files. The JSON configuration approach complements rather than replaces traditional main blocks, which remain recommended for script compatibility.
The server that runs without flags still answers to every transport